Okay, we're going to look at solving systems of equations, but now with a little bit more complicated ones. You notice now that if we just were to add these together, nothing would cancel out. It doesn't matter if I add or subtract, nothing will cancel out. And so what we can do is we can try to rewrite this equation as a similar equation so that the coefficients are the same. And I have a couple of different options here, but let's concentrate on the x variable. If this x variable were 4 times as large, it would be the same as that. So what I can do is multiply this entire equation by 4 and get a new equation of 8x plus 12y equals 16. Now obviously these are equivalent, it's just one now has been multiplied by 4, but the relationship between x and y really doesn't change. This bottom one I don't need to change at all because 8y and 8y here match up. So I'm just going to rewrite it below so that for me, I can see how they line up nice and easily. And now once I go to do my elimination, 8x, 8x, I do my subtraction, I get 3y equals 6, y equals 2, and I'm well on my way. I like to go back to my original equation because it's usually a smaller one. It hasn't been multiplied by anything. And just do my substitution. So I have 2x plus 3, and now I'm going to do y is actually equal to 2, equals 4. So I have 2x plus 6 equals 4. 2x equals negative 2. Therefore, x equals negative 1. And I have my solution to my system of equations. And finally, in this example, it's a lot trickier than the previous example because if I multiply this by a number, it's hard to get to 2. I'd have to multiply by a fraction, and likewise, to multiply this whole expression by a number, I'd have to multiply by 1.5 to get there, but then it makes the rest of this stuff messier. Likewise here with the 5 and the 7, there's no easy way to multiply. And by no easy way, I mean I can't just multiply by an integer. So one of the things that people do is they multiply both equations. And I know that 2 and 3, their least common multiple is 6. So if I were to double my first equation, then I'm going to end up with a 6x minus 14y equals a 4. And then for my second equation, I'm not going to double it, but I want it to be 6. So I need to obviously triple it. So I get 6x plus 15y equals a negative 9. And from here, I just solve using my techniques from earlier. So they're the exact same, so I'm going to subtract. Here I have negative 14 minus 15, so I get negative 29y equals 13. And then I have y equals 13 over negative 29, or I could just say that as negative 13/29. Now, of course, I have the option. I can go back and substitute it in this equation, or I can substitute it in that equation. But I've noticed that a lot of people have issues with fractions. And of course, it would work to do the substitution. And it's not as difficult as it looks, but I'd like to show just another method. Here, I multiplied by 2 because I was concentrating on my x terms. In the process, I ended up solving for y. If I wanted to concentrate only on my y terms and cancel those out, then I'd be left with just x. It'd be a little bit easier to solve. So I can think of this as I'm going to take this top equation, and now that I'm solving for x, I want to cancel out the y's. So I'm actually going to take the top equation and multiply it by 7. And then I'm going to get 20. Actually, if I multiply by 7, then I'm going to mess it up. 7 is my coefficient for the first one, so I don't want to do that. I want to multiply this top one by 5. So I'm going to have 15x minus 35y equals 10. And then I'm going to multiply this equation by 7. So that'll give me 14x plus 35y equals negative 21. And now it should be obvious what to do. These are the opposite signs, so I'm going to add them together, then they'll cancel. And I'm going to get 29x equals negative 11. Therefore, x equals negative 11 29ths. Now notice I couldn't avoid the fraction. My final answer is 11/29ths and negative 13/29ths. But I didn't have to substitute that value into one of these original equations and then solve all of those fractions to get the value for x. It's just a little bit easier way to solve it if your system of equation is complicated. If you're like a lot of people and as soon as you get an answer that's a fraction, you think you've done something wrong, one quick way to check is start with the original equation. It could be either equation. I'll start with 2x plus 5y equals negative 3. And then what you do is you just substitute in your values that you know for x and you know for y. So my x value from before was negative 11/29ths. My y value is negative 13/29ths. And then I just want to see, when I simplify this, will it equal negative 3? So I'm just going to leave that answer there for now. 2 times this gives me a negative 22/29. And then 5 times negative 13 actually gives me plus a negative 65/29. Negative 22 plus a negative 65 gives me negative 87/29. And we see that that actually ends up being negative 3. So since this is the same as that, I can verify that the point negative 11/29ths and negative 13/29ths is on this line. Therefore, it's an answer to this system of equations. It's a nice way to check. There's a faster way to do it on your calculator. Ask your teacher for some help.